Okay, most of them they have joined. Let us start the class. Very happy to see that most of the students they are coming in time compared to the offline. They are not coming late. They won't say, "Sir, bus is late." So such reasons are not there, and most of them they come and join in right time. So let us start a discussion. This is a summary. What you got? Most of the students they got 50% marks and above, but only few have got more than 80%, something like that. This is a result for the second IA. This is a summary, okay, compared to the first IA. I hope all of you will do well in your third IA. So let us continue the discussion. If you need a different UTP and LTP, this question was asked to you people, and some students they typed their answers. So let me wait for the 1 minute and let me see what they tell now. Wednesday, some alumni may address you, and 3-4 members have come forward to talk to you people. It may take 10 minutes, 15 minutes, and you can ask some questions to them. If they know the answer, they will tell. If I know the answer, I will tell. It doesn't mean you have to ask LIC. No. You can ask in general. You want to write GATE, you want to get a job in core company, you want to do MS, something you can ask. And even if you want particular, many alumni are there. Those who are in different countries, you can ask them to address you people. Anyway, I'm happy with my work. You should be happy with your work, what you are doing. That's all. Let me continue. Before I go to the next, let me ask you the one question. Yesterday, there was a talk from Gururaj Karajagi. Now, how many of you attended? Let me see their names. I repeat the question. Yesterday, there was a talk by Dr. Gururaj Karajagi. Okay, Akshay. Very happy to see you, Akshay. Thank you. Guru. Akshayji, Vinay Kumar has attended, thank you. Manjunatha Dudimani, very good. Muthu Sunigar has attended, very good. And I attended for 20 minutes, okay, no problem. Rakshita has attended, Basava Devargudi has attended, and very good. At least a few students they have attended. Somehow they got a time and they have attended. Others were so busy. I don't know, they won't get a time to attend such things. How many minutes you people spend for your WhatsApp and other social medias? If you spend it for becoming a good human being, it will be better. Okay, I hope these people, these students have got benefited from that talk, definitely. Even though it's not a syllabus or LIC or something, analog communication, for the life, those things are very important rather than all these what we teach. According to me, there should be a separate subject for that, for all engineering, for all colleges, not only engineering, because those are very important along with this, whatever the technical stuff we are teaching you. Let me go to the next. The equations, we can copy down. Vi equal to I2 into R1. I2 equal to V0 by RF. Just copy down the VUT, VLT equations. I'll wait for 1 minute. Here also we connect the diodes whenever you want a different UTP and LTP. So don't say these are all out of syllabus. One should know should have a common sense. Thinking ability is very, very important. Bugging up as it is, getting a high score, yes, grade in all the subject, you never get any job at all. If you get a job also, you may not survive for a longer time. So please remember these things. You have to learn how to learn and how to use your brain, how to think. Now, let me ask you this question. Can we use an AC voltmeter to measure the amplitude of a square wave? maybe a triangular wave, or maybe a sawtooth wave. Either you can say yes or no. All the students have told yes only. I am happy to see your answer, because at least right or wrong you are coming forward and you are telling your answers. At least you will come to know what you know is correct or not. If you tell like this, even I'd come to know whether I should explain or not. Very good. Anybody is saying no? You can type now, because everybody has typed yes. Anybody want to say no, sir? We can't measure. Okay. Let me continue the discussion. We are going to discuss about now peak detector, and this again video is already available in the YouTube, but nobody has seen this video. Nobody is answering. I told you people, given the link, it is there in your WhatsApp, but you should take a little pain to click it. That's all. Okay. Peak detector, I have already uploaded the video in the YouTube, and let me repeat this again. The same question just now I asked, but the answer is basically the AC voltmeter is designed to measure the RMS value of the pure sine wave. It is designed for the measurement of a pure sine wave, not for any other. If I have a random waveform, I can't use a AC voltmeter for that. Solution is just measure the peak value of any non-sinusoidal waveform. Something is there. Say today's temperature variation is there. I want to know the peak of value of that. So we make use of a peak detector for such thing. And this is the simplest example I can give you to find the peak value of a waveform. Why this waveform, sir? See, highest temperature of that day. Say temperature is varying, and I want to know that day a highest temperature. I don't want to see any other. In the news and all, they say highest temperature was this much today in this particular city. I want only the peak value. I don't want other value. So such things can be got using a peak detector. This is already uploaded in the YouTube. Hope at least one student might have seen out of 70. Anyway, let me continue the discussion. All of you know the half-wave rectifier. So when I'm applying like sine wave, if a zero voltage is here, automatically a negative part will be clipped and only the positive part will get, because it conducts in the positive half cycle. That time it will be a forward bias. This is known to you people. And positive peak detector, what we are discussing. See, this is a waveform, what I am giving. Say something random I am giving. I need only the peak value. So this circuit does that. Try to understand how. So I am giving the input, and during initially its charge is nothing. So whatever the positive voltage increases there, that time it will conduct. Automatically the output also you will find increasing. After this will become less, but this is more. Automatically this become reverse bias, and diode doesn't conduct. Then voltage will remain as it is. Try to understand. Next, again the input is increasing above whatever the capacitor voltage is there. So therefore, automatically the diode conducts, and again you will get an increase in the voltage. After this, now input becomes less, but charge at the capacitor is more, and it will not discharge, and automatically the diode will reverse bias, and you will get a same voltage. This is a basic concept how a positive peak detector works. I hope all of you got the idea, and the same thing I am mentioning again, using for your convenience. During this time, automatically the diode conducts because it's increasing voltage, and here assumption is that capacitor will not discharge at all. We don't have any load through which it can discharge. Even load is there, it's very high impedance. Then after this, what will happen? So here the voltage remains same because the input voltage is less. Because of that, capacitor voltage will remain same because it's not discharging. After this, again input is increasing above capacitor is automatically charging again. So after this, the input is decreasing, and because of that the output remains same. Because of that, output remains same, it will not discharge. So this is the way how a peak detector works. I'll give 1 minute. You people can copy it on the circuit and any waveform. Now it's a voltage follower. All of you know how it works, and V0 will be equal to Vin. So V0 equal to Vin. So let me ask you the same question again. When output equal to input, so जो कुछ हम दे रहे हैं इधर, the same thing will come here. Then why we should spend the money for this? I can take a single stand between this point and this point. Why the hell this? I had to include unnecessarily. Can you answer this? So Vin equal to whatever I am giving, V0 will become equal to Vin. Can I connect a single stand wire instead of the operational amplifier? Because I have to pay for that. No? Unnecessarily I have to spend the money. What is the purpose of this voltage follower circuit? You have done the experiment. You have spent hours together, and even in the class also we have discussed, and about this only experiment YouTube video is uploaded. Again this theory YouTube video is uploaded. Very good. Siddharth Nabhapur is telling, because it's a loading effect. To avoid the loading effect, we use as a buffer this voltage follower. And most of the students, they have already gone through that video, or even in the class also have discussed. Even you have discussed in the lab also, because you have completed these experiments in the lab. The peak detector circuit I have drawn, and to draw this I have taken a lot of pain and I have taken a lot of time. And we cannot take test circuits from the textbook or from somebody. It will become a problem, and we should not copy from others without their permission. So usually I tried my level best to write myself. Take a 1 minute and copy it on this peak detector. Try to understand. During positive half cycle, given the non-inverting terminal, this will become a positive, whether D1 will conduct or D2 will conduct. Most of the students are telling D1 will conduct, sir. Very good. I'm so happy to see everybody's name in the chat box. Everybody is saying, sir, D1 will conduct. So if the students are so active, teacher will become also active. Now D1 will conduct, automatically the capacitor will charge. So D1 conducts, capacitor charges. And now you can note down this one line. I'll wait for 30 seconds. Now consider during negative half cycle, D1 is off. So whether D1 or D2 will conduct, no, negative half cycle means automatically this time D2 will conduct. And because of that, there is no chance that capacitor charging, D1 is open. And the IB is negligible. And R will be very high, else we use a buffer. That's all. This is about a working of this particular circuit during a negative half cycle. So you can copy down another one line. I'll wait for you people for the 1 minute. You copy down. R is used to protect the operational amplifier against excessive discharge current when supply is off. This is the R wire connected. D2 conducts during a negative half cycle and prevents op-amp from going into negative saturation. And how to detect the negative peak? Somebody can think and copy down 1 or 2 lines from this. Answers are correct. Abhinandan. Anusha also told same. Instead of only reversing D1, you can reverse a D2 also. When you reverse both, definitely you can go for a negative peak. And this is a summary. I want you people to read it once, understand this. Go through once. I'll give 1 minute. We have discussed the peak detector. Now we are going to discuss about the sample and hold circuit. What do I mean by sampling? Can you tell? So to convert the AC to DC, we go for a sampling. All answers are correct. Now I want answer from you people. Signal between the discrete, digital and analog. I think this once I asked. Let me know how many of you will answer at least now again. Very good. A particular character in the discrete there are limited points. Okay, in discrete and continuous she told, but should include one more about a digital also, if possible, Aditi. All these two I agree, and one more you can include. Very good answer. Most of the students, they are typing their answers, so good to see their names in the chat box. Digital signal is the form of binary, sir. Very good, Pavan Guttis. And Totashri is telling, oh, Sajjaner, no? Surname I forgot. Digital imply we it's only in terms of zeros and ones. So correct, Totashri is correct. And even this sample and hold circuit video is already available in the YouTube, and I told you people to go through. And usually in the offline class, we ask you people to write an input and output for this block. A to D converter is a block, and all of you write down in your notebook some input and output. If you want, you can type also in the chat box. I will not ask you to draw in the chat box, but hope all of you have written in your notebook, and you can compare after our discussion. A to D converter, some input you have to give, some output you have to show. Okay, what you have drawn in your notebook, can you type that in the chat box? Before I ask that question, the heading I shown you people, sample and hold. And most of the students, they give the answer. We convert analog to digital. That's the reason we go for sampling, sir. Then I ask the question, can you write an input to the analog to digital converter? Something input and something output I asked you to write. And all are telling, for A to D converter, you give directly the sine wave as an input. Then previous question intentionally asked, so that at least you people will think in that direction. Now I'll give another 1 minute. Can you tell what is the input to the A to D converter? Anyway, we have a separate chapter on that. We'll discuss there, but I want you people to answer now. I'll give another 50 seconds. I'll wait for you people to say something in the chat box. I'll be happy to read your names. Thank you for your answers. Now let me go to the next. Now, it is a part of a circuit I am discussing. During a positive portion of a Vs, what I am applying, V in, MOSFET conducts, all of you know, a drain to source will be closed. This is when it is high, automatically A becomes equal to B. I can say this is a short circuit. And if it is a 0 is applied, this A and B will be open circuit. This is a basic thing one should know, and I want you people to copy down this. I'll give the 1 minute. This is a gate I am applying, high and low, and whenever it is a high, drain and source will be short circuited. Whenever it is a low, it will be open circuited. This is a part of a circuit I am showing you people. So this is a complete circuit. I want you people to copy down, and we'll have a discussion. Take a 1 minute. The question I asked, A to D converter input and output. Detail we are going to discuss in the A to D converter chapter. If you copy down this circuit, and we'll conclude today's class. Those who have copied, they can leave the class so that they can attend the next class from 10 to 11. Thank you for attending the class. Take care, be safe, and take interest in learning. Thank you. Thank you all of you. If anybody want to talk, I'll be here for another 2-3 minutes. Good morning, madam. ನಮಸ್ಕಾರ ರೀ. ಹೌದ್ರಿ, ಮೊನ್ನೆ ಸ್ವಲ್ಪ ಮಾತಾಡ್ಬೇಕು ಅನ್ಕೊಂಡಿದ್ದೀವಿ ರೀ. ಟೀಚರ್ಸ್ ಅಂದ್ರೆ ನಮ್ಮಲ್ಲಿ ಅಟ್ಲೀಸ್ಟ್ ಹೆಂಗೆ ನಡೆದೈತಿ, ಹುಡುಗರು ಏನು ಡಿಫಿಕಲ್ಟೀಸ್ ಫೇಸ್ ಮಾಡಾಕತ್ತಾರ. ಈ ಪೆಂಡಮಿಕ್ ಇರೋದ್ರಿಂದ ಅವ್ರ ಹೆಲ್ತ್ ಬಗ್ಗೆನೂ ಕಾಳಜಿ ತೊಗೋಬೇಕು ಹುಡುಗರು. ಅದಕ್ಕೆ ಪೇರೆಂಟ್ಸ್ ಜೊತೆ ಸ್ವಲ್ಪ ಮಾತಾಡಿದ್ರೆ ಆಯ್ತು ಅಂತ ಅವತ್ತು ಹೇಳ್ತೀನಿ ರೀ. ಸರಿ ರೀ, ಹೆಂಗೆ ಹುಡುಗರಿಗೆ ಒಳ್ಳೆ ಟೀಚರ್ ಬೇಕಾಗ್ತದೆ. ನಮಗೆ ಟೀಚರ್ಗೆ ಒಳ್ಳೆ ಹುಡುಗರು ಸಿಗೋದು ಅಷ್ಟೇ ಖುಷಿ ಇರ್ತೈತೆ ರೀ. ಭಾಳ ಚಲೋ ಮಾಡ್ತಾಳೆ, ಭಾಳ ಶಾಣೆ ಅದ ಹುಡುಗಿ. ಡೆಫಿನೆಟ್ಲಿ ಒಳ್ಳೇದೇನಾದರೂ ಮಾಡ್ತಾರೆ. ಪೇಪರ್ ಪ್ರೆಸೆಂಟೇಷನ್ ಮಾಡಕತ್ತಾಳ್ರಿ. ಡೆಫಿನೆಟ್ಲಿ ಈ ವಯಸ್ಸಲ್ಲಿ ಯಾರೂ ಮಾಡಿಲ್ಲ. ಇವಳು ಮಾಡ್ತಾಳೆ ಅನ್ನೋ ಭರವಸೆ ನನಗೈತಿ. ಮಾಡಿದ್ಲಂದರೆ ಡೆಫಿನೆಟ್ಲಿ I2 ವಿಲ್ ಬಿ ಹ್ಯಾಪಿ. ಅದು ಅವಳಿಗೆ ಖುಷಿ ಕೊಡುತ್ತೆ, ನಿಮಗೂ ಖುಷಿ ಕೊಡುತ್ತೆ.